All right, let's dive into an electrical mystery that has probably frustrated every single one of us, especially around the holidays. We're talking about the all or none circuit, and today we're going to figure out exactly why it fails so spectacularly.
You've been there, right? Staring at this totally dead string of lights, and you just know it's one tiny little bulb that's causing all the trouble. It's a classic, infuriating problem, and in this explainer, we are going to get to the bottom of why it even happens.
Okay, so the first piece of this puzzle is understanding the type of electrical circuit we're looking at. And, this isn't just about twinkly lights. This is a really fundamental idea in how electricity works.
And here's our culprit, the series circuit. The most important words on this slide are one single path. I want you to think of it like a one-lane road with absolutely no exits. Every car has to travel along the exact same route, one right after the other.
So, how does this whole single path thing really work? Well, to figure out the flaw, we've got to understand the flow. Just imagine for a second that you're a tiny little electron starting your trip from the wall socket. So the current kicks off its journey, zips through that first light bulb, and then immediately, boom, it's onto the second one, then the third, and so on, all on a perfect single file line until it makes it all the way back home. There are no detours, no shortcuts, just one straight linear path.
Now this is where it gets really interesting. There are basically two golden rules for a series circuit. First, the current, that's the flow of electricity, is exactly the same at every single point in the line. But second, the voltage, which is kind of like the electrical pressure, it gets divided up. Each and every light bulb takes its own little slice of the total voltage. Just tuck that fact away because it's going to be super important in a minute.
And this right here, this brings us to the absolute heart of the problem, the fatal flaw of this whole design. It's the very thing that makes this circuit both incredibly simple and unbelievably fragile.
This quote just nails it. It's a totally binary system. Either everything is on and working perfectly, or absolutely nothing is. There is no middle ground. The second one part fails, the whole system just goes down with it.
So what's actually happening when that little filament inside one tiny bulb breaks? Well, that single path for the electricity is now totally broken. It's an open circuit. It's like the drawbridge on our one-lane road suddenly got raised. All the traffic just screeches to a halt, and the electricity can't finish its journey. No flow, no glow. Simple as that.
Okay, so you're probably thinking, wow, this sounds like a pretty terrible design. Why on earth would anyone ever use it? And you know what? That is a totally fair question. But like with most things in engineering, it really comes down to a trade-off, the pros versus the cons.
So on the plus side, its simplicity is a big deal. Less wire means it's cheaper and way easier to build. It's also perfect for safety devices like fuses, because they're designed to break the circuit and stop the current during a power surge. But, and this is a big but, the disadvantages for everyday stuff are massive. Remember how the voltage gets shared? Well, if you add more lights, each one gets a smaller piece of the pie, which makes all of them dimmer. But it's that last point, the one about voltage, that's the real deal breaker for your house.
This right here is exactly why you will never see the outlets in your home wired in series. Hooking up major appliances this way doesn't just make them work badly, it creates a huge danger.
Take a look at this number, 1,100 volts. Yeah, according to the source material, if you just wanted to connect 5 standard 220 volts appliances in a series, you need a power supply of 1,100 volts to run them. That's an incredibly high and dangerous amount of power, which makes it totally impractical and just flat out unsafe for any home. And speaking of danger, that brings us to our last and honestly most important section. Because this isn't just theory, right? Electricity is a powerful and potentially deadly force that you have to respect.
So the bottom line here is simple, and it's non-negotiable. Safety has to come first. This is exactly why the outlets in your house use a whole different system called parallel wiring. It's specifically built to be reliable and safe and to avoid this all-or-none problem completely. That's why messing with your home's wiring isn't just a bad idea. It can actually be illegal. It is just not worth the risk.
So while it's really cool to understand why those old lights fail, the biggest takeaway here is to just leave the actual wiring to the experts. The next time you see a string of lights where only one bulb is out, you'll know you're actually looking at a much smarter design, probably a parallel circuit or one with a clever little bypass that lets the electricity skip the broken bulb. It's the elegant fix to this classic holiday headache. Thanks for joining me.